Today we're going to introduce our first connective, which is the conjunction. We're also going to introduce a useful tool, namely truth tables, and propositional forms, just a useful notion too. A conjunction joins two statements to form a more complex one. And as we said, it corresponds to an important extent to the English term and. For instance, suppose that we have two sentences. Al sings, Beth dances. In English, the conjunction and joins them to produce the complex sentence Al sings and Beth dances. In propositional logic, a conjunction is defined as follows. A conjunction of two statements is true whenever both of the conjuncts are true and false otherwise. The conjuncts are going to be the component sentences of the conjunction. And so here in this device, we see what happens to the truth value of the complex sentence, the conjunction Al sings and Beth dances, depending on the respective truth values of the components, namely Al sings and Beth dances. And so we can see that the complex sentence Al sings and Beth dances is only true whenever both Al sings and Beth dances are true. In any other case in which at least one of them is false, the complex sentence, the conjunction, is going to be false. And this makes sense, right? Because that's the way in which the English and works. In propositional logic, the conjunction is represented by the ampersand. And so we substitute and with the ampersand. Now, there are other ways in English of expressing a logical conjunction besides and. So if you have Al plays and Beth works, well, that is a conjunction, right? Because it's true even only if both conjuncts are true. But, and even though, although, etc., they also introduce conjunctions. Al plays but Beth works is only going to be true whenever Al plays and Beth works are both true. And the same with Al plays even though Beth works. Although Al plays Beth works, Al plays yet Beth works, Al plays however Beth works, or simply Al plays Beth works. All of them are going to be can be expressed by means of the ampersand. And so, as far as propositional logic goes, they are all the same. Of course, in English, they are not exactly synonymous because, as you see, but and even though and yet, they introduce some sort of contrast. But propositional logic only looks at whether the sentences are true or false. And in that sense, and, but, although are equivalent, right? When they join sentences, that sentence is true only when both of the conjuncts are true. Another important notion is that of propositional forms. Sometimes in propositional logic, we use letters to abbreviate things. For instance, a lowercase p or q or r can stand for any sentence, no matter how long, right? For instance, P could stand for Al sings, or for Al doesn't sing, or for Al and Beth don't both play tennis, although Al plays tennis and Beth doesn't. Either Claire plays the trumpet or Dave plays the clarinet, and every sentence you can think of. So we can say that each of this sentence is a substitution instance of P. You can also think of P as being a box that can contain sentences, such as Al sings, Al doesn't sing, Al plays guitar, or Beth runs, and indeed, as we said, any sentence. You can also have more complex propositional forms, which involve connectives. For instance, every conjunction is of the form P ampersand Q, where P and Q are each a placeholder, as we saw. And again, you can see P and you can see Q as boxes, as placeholders, where you can put sentences. So you can use propositional forms as templates that we can use to make sentences. So you can see here that the form that we have in the previous slide is conformed by two boxes, which are represented by P and Q, united by an ampersand. notice that the ampersand has to be there. And again, you can substitute any sentence you want in the boxes, that is, in the places marked by the P and Q. The only requirement is that between them, you're going to have an ampersand. For instance, when we substitute our P's and Q's with sentences, which would be equivalent to putting sentences in the boxes in our present image, well, we obtain another sentences. And the sentences that we obtain in this way, we call substitution instances of the form. In this case, the form P ampersand Q. Let's take the form we've been working with. That is, the ampersand surrounded by the letters P and Q. Now, which of the sentences in the right column are substitution instances of this form? Well, the key to answer this question is to see if we could take the empty form and then arrived at the sentence in question simply by substituting sentences for the letters that we had. So let's see that the last three are not substitution instances. For instance, Al sings doesn't have an and it cannot be formed by filling this form. In propositional logic, we often talk about propositional forms rather than about specific prepositions. And again, the propositional forms are designated by lowercase letters such as P and Q together with the connective symbols, right? And we already saw, but well, this is the definition of the ampersand, right? A letter, a sentence conformed by the ampersand is only going to be true when both components are true. Truth tables. We'll talk more about truth tables later, but for now, let's just introduce them. A truth table describes how the truth or falsity of a complex sentence depends on the truth or falsity of its components. So here we have a truth table for conjunction. And clearly then, a truth table for conjunction describes how the truth or falsity of the conjunction sentence depends on the truth or falsity of the conjuncts. Suppose that we want to make a truth table for P ampersand Q. Well, first of all, we have to identify the components, which in this case are the letters P and Q. Then we draw the table itself, and then we have one column for the conjunction and one column for each of the components. Now, why does this table have 4 rows? That is because the number of rows in a truth table for a sentence is arrived at as 2 to the power of n, where n is the number of atomic sentences involved. In this case, there is only 2 atomic sentences, P and Q, so it's 2 to the power of 2, 4. The next step is to assign values to columns, where those values are true or false, abbreviated by T and F. So let's begin with the leftmost column, in this case P. And the principle is half are going to get T and half are going to get F. So if we have 4 rows, 2 are going to get T and 2 are going to get F. If we had 8 rows, then 4 would get T and 4 would get F. Now we continue with the next column to the right. And this time the principle is a quarter going to get T and a quarter going to get F, right? So in this case, we have TF, TF. Now, if we had 8 rows, then the distribution would be 2 T's followed by 2 F's, followed by 2 T's, followed by 2 F's. The next step is to assign values to the main column, right? And the last step. The main column is the one where the ampersand appears. And well, how do we assign values? Well, just use the rule associated with the connective. And so we know that the ampersand just gets a T whenever both of the components, P and Q, get T's, and otherwise they get F's, right? So it's T, F, F, F. Okay, this is all about truth tables for now.